Good morning, students. Today is day 2 of points, lines, and plans. Yesterday, we talked about point, the definition of point, a line, and a plan. Today, we're going to continue the definition of two other elements in this lesson, which are a line segment and array. Now, yesterday, if you remember carefully, I did quickly mention about what are the differences between a line segment and a line. Today, we're going to talk more about that. We're also going to discuss about some basic postulates in trigonometry, and at the ending, we're going to work on some problems. Okay, so let's go. So, line segment. What is a line segment? A line segment is always has a the beginning and an end point. Okay, so let's say I have point A and point B. When they give you 2 points, you can always draw a straight line. Now, this is not called a line, however, because we know a line will goes on forever on both direction. Okay, it does not stop. A line segment, on the other hand, has the beginning point and the ending point. It is restricted. So that is why it's called segment, because it's only a part. It's only a part of a line. It's only a part of a line, and it consists of one beginning point and one ending point, and all the collinear points between them. So just like a line, right? In between of my beginning point and the ending point, there are many more collinear points in the between of the line segment. Okay. Now, the line segment is named by its beginning point and ending point. Okay, I'm going to copy that. Okay. So, let's say in this case, I have a line segment AB. How can I write that in terms of trigonometry, and they understand that that is the line segment? So the way I'm going to write it is A, B, because A is my beginning point and B is my ending point. On top of AB, I'm going to draw a bar. Okay, a bar has no errors because that is a segment. Okay, so a bar with no error. No arrows. Sorry, arrows, not error. Okay. And for a line segment, the order doesn't matter. So you can either say A, B, or B, A, because there's no direction for the segment. Just like the plan, the order does not matter. So keep that in mind. Now, so that is line segment. Let's moving on to ray. So There's one more special type of line that we need to talk about, and it's basically a combination of a line segment and a line, and that is called array. Okay, so let me say that again. Array is basically just a combination of a line segment and a line. Why do I say so? Because array, it has a beginning point. Okay, let me draw something. Array, it has a beginning point, but it has no ending point. So let's say this is A. The array just keeps going on forever in one direction. Okay, so we only put an arrow on the end to indicate that it keeps going. Now, let's fill in the definition. Array is also a part of a line. It consists of one, I don't like to call this its end point. I want to call this its beginning point. Sorry, beginning. Okay, it consists of one beginning point and all of the collinear points that extends to infinity. So just exactly like the line or the line segment, on a array you can have like many points on there. Okay, many points on there. Let's say I might want 2 points only, but in a space you have to know that it has more than 1 point on array. In fact, it is infinite points on array, just like a line or a like segment. Okay, so let's say I have point B or point C. Okay, now let's continue with the definition. Extends to infinity in the opposite direction. It is named by the beginning point. And one other point on the array. Okay, there is one single arrow symbol above 2 letters with the arrow pointing away from the beginning point, pointing away from the beginning point. All right. The definition seems a pretty long, but it gives you the full information. Now, how can you write array in geometry? It said it named by the beginning point. So my beginning point here is A, and then with one other point on the array. So you can choose whichever point. So in here I have point B, so I'm going to write A, B, and then above of my letter A, B, I'm going to draw a symbol with one arrow pointing away from a beginning point. okay? Because the direction is going from A to B to C and go to infinity. You can also write as segment AC. Another way to write is BA. However, if you write like BA, make sure your arrow pointing correctly, because we know that the A is our beginning point and it's going towards the point B, so that's why the arrow have to go in this direction, okay? Similarly, if you want to write CA, make sure your arrows going in the correct direction, okay? From A, it goes from A to C. But the easiest way is to write from the beginning point to another point on the ray and then draw your arrows like that, okay? The incorrect way to write this, let me give you some example, are you write BA, you write BA, but your arrows is pointing to this direction. So when you write like this, people will understand B is your beginning point and A is another point on the ray. So this is what it looks like, okay? So that is not correct. If you compare these two rays, those are not the same ray because it's have different beginning point, okay? Another incorrect way, which are C, R, and it pointing towards this direction, or B, C. Okay, so those three are the incorrect way to write the ray. Now, opposite ray. Opposite ray are two collinear rays with the same beginning point. They always form a line or straight angle. Okay, so for example, opposite ray. Let's see if I have opposite ray, they have the same beginning point. So let's say I have the beginning point is B and then I have another point on my ray and I have another point C on that ray. My opposite rays are B, A. Okay, remember my starting point B. That's why my arrow's pointing this direction. And the opposite ray of BA is BC. Okay, and this is a straight line. Opposite ray form a straight line or straight angles. What if you have these two rays? Let's call this is D, DE, DC. Are those two rays, DE and DC, opposite ray? The answer is no. This is not opposite ray, even though it has the same beginning point, which is D, right? But it does not form a line or straight angle, so it does not qualify the requirements of opposite ray. Okay, so now let's move on to some statement. Okay. Use always, sometimes, or never to make a true statement. The first one, 4 points are, okay, blank coplanar. Is that 4 points are always coplanar, 4 points are sometimes coplanar, or never? The answer is 4 points are sometimes coplanar. Okay, sometimes. Why is that sometimes? Let's take a look here. I have a plane. I have 4 points, right? The first case is my 4 points are on the same plane, which is coplanar. That is the first case. However, the second case, I also have 4 points, but this point right here is outside of my plane. So this is non-coplanar. So that's why we say sometimes. Okay, it's not always, it's not never, it is sometimes, because there's one case that makes it not always coplanar with 4 points. Okay. Number 2, a plane containing 2 points of a line blank contains the entire line. So remember, to create a line, we only need 2 points. Okay, so if a plane containing 2 points, it always contains the entire line. And let me show you. Okay, I have a plane right here, and I have 2 random points on my plane. From 2 points, you can always draw a straight line. Okay, so that's why it always contains the entire line if the 2 points are on the plane. Number 3, 2 lines blank meet in more than 1 point. What do you think? Meet here means intersection. So let's say 2 lines intersect. 2 lines always meet in more than 1 point, or sometimes meet in more than 1 point, or never meet in more than 1 point. The answer is 2 lines always meet or always cut in 1 point. So the answer is always 2 lines always sorry. 2 lines always meet in 1 point. Okay, moving on. Four. 3 points are always coplanar. Why is that always? So let me give you the first case. Case 1 and case 2. Let's say if I have 3 points that are collinear. Okay, this point here. If I have 3 points collinear, it would create a straight line like this. And they're also on the same plane, right? So these 3 points, they collinear. And they coplanar. What if you have 3 points, but they are not collinear? So let's see, I have a point right here. It creates a triangle. But these 3 points are still on the same plane, even though they're not collinear. So in this case, I have 3 non-collinear points, but they are coplanar. So no matter if the 3 points are collinear or non-collinear, 3 points are always coplanar, meaning on the same plane. Okay, that's number 4. Number 5, 2 planes blank intersect at exactly 1 point. What do you think? 2 planes never intersect in exactly 1 point. So for 2 planes, it's always intersect in one line, not one plane. Sorry, not 1 point. Okay. This is always. Okay. So let's moving on to some postulate. Postulate. So what is a postulate? A postulate is an acceptable statement of fact. Those of fact. In here I have 1, 2, 3, 4, 5 postulate. Okay, so the first postulate, if I have 2 points, through any 2 points there is exactly blank line. What is the answer? We've been talking about this pretty often so far. So through a 2 point, there's one and only line. Okay. To create a line, you only need 2 points. Postulate number 2. If 2 lines intersect, they intersect in exactly 1 point. Okay. Postulate number 3. If 2 planes intersect, then they intersect in exactly one. This is a line. So if 2 planes intersect, they intersect in exactly 1 line. Postulate number 4. Through any 3 non-collinear point, okay, non-collinear point, there is exactly one plane. Okay, so again, to create a line, you need 2 points. To create a plane, you need 3 points. 3 non-collinear points. Okay, the last postulate. If 2 points are in a plane, then the line containing them is also on a plane. Or in another way, you can say, if 2 points are in a plane, the line that going through them is also on the same plane. Okay, so these are the postulate, and I have the picture for you to easy visualize our postulate. Now, there are 3 practice problem right here. This is going to be your homework for today. Okay, so after watching this video, you're going to finish for me these 3 problem, and this is going to be due by Thursday when I'm back. Okay, so that is it for today. I'll see you on Thursday. Bye. Have a good day.